In this section, we are trying to graph a function, okay? So in our last class, we use a graphing tool to graph this function, okay? Today, we will graph using our points. So let's start with our function h of s, okay? So we have a function h of s equals to negative 3s squared plus 4. This is our h is a function, s is a input, h of s is our output, okay? Now to graph this, here the highest exponent of our input is 2. It means we have this quadratic function, and quadratic function has a parabola, okay? So to graph, we need a points. So we have an input s, okay, that is our input, and our output is h of s. Our output is h of s. In general, our input is x, okay? So this is your x coordinate, this is your y coordinate, okay? Do not get confused. Input is x, output is y, okay? So they have picked s to represent input and h of s to represent output. Now let's find our output given that we know our input. So we know the domain for this function is any real number. So let's pick input. You can pick any input and let's find output. So let me start with a negative. Okay, let me start with positive 3. So if our input is 3, what will be output? If our s is 3, what will be our output? You replace s by 3. Okay, so we have negative 3 times 3 squared. 3 squared is 9. 9 times negative 3 is negative 27 plus 4 is negative 23. So our output is negative 23. So input first, then output second, negative 23. This is 1 point, okay? S, h of s. This gives us the point. Because our input is x, our output is y coordinate. Now let's take our input s equals to 2. If our s is equals to 2, what will be the output? You replace s by 2. We have negative 3 times 2 squared. 2 squared is 4. Negative 3 times 4 is negative 12 plus 4, that is negative 8, right? So 2 negative 8 is the second point. Now since this is not a straight line, we need more points here, okay? If you have more points, you get you'll get exact graph here. Now let's go take 1. If our input is 1, output will be negative 3 times 1 is square, that is negative 3 plus 4, that is 1. So 1 is, let's take 0. So if our input is 0, you replace s by 0, we get 4. So 0, 4. Now let's take some negative number, okay? So let's take negative 1. If our input is negative 1, what will be our output? Negative 1 is square, that is positive 1 times negative 3. Negative 3 plus 4, positive 1. So negative 1, 1. Now let's take negative 2. If our s is negative 2, what will be our output? Negative 3 times negative t square. Negative 2 square is positive 4. Positive 4 times negative 3 is negative 12 plus 4, that is negative 8. So we have negative 2, 8. Now let's take last negative 3. If our input is negative 3, our output will be negative 23. So negative 3, 23 is our next point on the graph. Now we plot these points and connect the dots, we get the graph, okay? Now in this case, what do we call our horizontal axis and what do we call our vertical axis? In general, our horizontal axis is x-axis, right? Our vertical axis is y-axis. Now in this case, what is our horizontal axis? It's input. So what do we have as our input? What represents input here? Yes, so S is the horizontal axis. And what about the output? Output is h of s, that is the vertical axis, okay? h of s. So your input is horizontal axis, output is vertical axis. In general, we have x for horizontal, y for vertical. But in this specific function, our s is the input. So horizontal axis is s. Our output is h of s. So our vertical axis is h of s. Now let's say this is -2, -4, negative, sorry, it's not negative, it has to be positive, right? I'm sorry, we have positive numbers, so this is 2, 4, 6, 8, 10, 12. So this is 2, 4, 6, 8, 10, -2, -4, -6, -8, -10, -2, -4, -6, -8, -10, and so on. When you graph, make sure to have this scale, okay? You must have these numbers. Without this scale, you can't graph. Now let's start with graphing 3, -23. So where is 3? So this is 3 here, -23 is, okay, so let me take somewhere here, okay? So -23. So this is our 3, -23. Now let's plot 2, -8. So this is 2, -2, -4, -6, -8. So this is 2, -8, 1, 1. Okay, so 1, 1 is somewhere here. This is 1, 1. 0, 4. So 0, 4. So this is 0, 4. Then -1, +1. So -1, +1 is here. -2, -8. -2, -8 is somewhere here. And -3, 23 somewhere here. Okay. Now we connect all these dots and our graph looks like this. Okay. And this graph, or sometime we might get the graph that open up. So this graph are parabola, okay? Every time if you have a quadratic function, you always get a graph like this. You do not get a straight line. You get a straight line when we have a linear function. This is a quadratic function, and for every quadratic function we get a parabola. Okay, any question up to here? You can pick any input and you find the output. Your input is x coordinate, output is y coordinate. X and y together gives a point. Connect all the points and you get a graph. Okay? All right, now let's go to the next function. So what do we have our next function? Okay, we have g of t equals to, so we have g of t equals to -t cube plus 1. Now here, what is our input? Our input is t. T is the input. What is our output? G of t. G of t is the output. Okay, the highest exponent for the input is 3. And we call this function a cubic function. Okay, this is a cubic function. We know all real number is a domain for this function, so we can pick any number. So let's take some positive numbers, some negative numbers. Okay, so let's start with -3. So if our t is -3, what will be our output? What will be our g of -3? So you replace t by -3. So we have negative, and what is the cube of -3? It is -27. -3 times -3 times -3, -27. And we have negative in front, so that makes +27 plus 1, 28. So this is 28. Let's take -2. So if our t is -2, you replace t by -2. Cube of -2, that is -8. We have a negative in front, that makes +8 plus 1, 9. So we have a 1 point here, -3, 28. So t, g of t, it gives a point. So second point is negative 2, 9. Let's find third point. Let's take negative 1. If our t is negative 1, so what will be the output? No. Is it 0? So cube of negative 1 is negative 1. And we have negative here. That makes positive 1 plus 1. That is 2. Okay. So negative 1, 2. If our t is 0, then we get 1, 0, 1. If our t is positive 1, now we get 0. So if our t is 2, that is negative 8 cube, no, that's a negative 8 plus 1, that is negative 7, 2, negative 7. Now let's take one more last, 3. That's negative 27 plus 1, negative 26. So 3, negative 26. Okay. Do you have any question up to here in finding the input? Now, since we know this function has a domain all real number, you can pick any number here, okay? So it's not that you always have to start from negative 3 or you always have to start from positive 3. You can take any real number as your input. Once you have your input, you replace that input for t and find the output. Input, output together in our parenthesis gives us a point. Okay. Now let's plot this point in our system here. Now in this case, what do we call our horizontal axis and what do we call our vertical axis? So what is our horizontal axis? It's always input. And what is input here? T. So T is input. It means T is horizontal axis. Okay, what is our output? G of t, and our output is always vertical axis. Okay, input is always horizontal axis or it is x. Our output is always vertical axis, that is y. So this is 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, negative 2, negative 4, negative 6, negative 8, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, and so on. Now let's plot negative 3, 28. So negative 3 is on the left. So this is negative 2, this is 2, this is negative. So negative 3 is somewhere here and positive 28. Okay, so let me take somewhere here. Okay, so this is negative 3, 28, negative 2, positive 9. Okay, this is 2, 4, 6, 8, 9 is here. So negative 2, positive 9 is here. Negative 1, 2. So negative 1 is here, 2 is here. 0, 1. So 0, 1 is here. 1, 0. Oh, no, this is not 2. This is 1, 0. 0, 1 is here. Okay. So this is 0, 1. 0, 1 is on the vertical axis and this is 1, 0. Now 2, negative 7. 2, negative 7. Negative 4, negative 6. Okay, somewhere here. 3, negative 26. Okay, 3, negative 26, somewhere here. Let's say. Now we connect all these dots and we get a graph here. So this is a graph for our cubic function. And if you have a cubic function, you always get a graph this that looks like this, or you always get a graph that looks like this. Not exactly same, but very similar. Okay, so this is a cubic function. Okay, any question on this part?
So how many example steps for essentially would it be like 3 for doing like the points and then graphing it?
So like how many points? want to pick here. Now, so if you, okay, now for a straight line, 2 is always enough, okay? And if your function is not a linear, at least like 6, 7 or 5, okay, so we have 1, 2, 3, 4, 5, 6, 7, right? So at least like 6, or if you have more points, means you are getting more accurate graph, okay? But since this is a cubic function, and if you know your graph looks like this, then yeah, at least like a 6 plus, okay? So if you have 6 plus, and make sure to choose your input positive number, negative number, and including 0, okay? So select some negative number, select some positive number, and 0, and that will give you somewhat accurate graph. So this is the case for our cubic function. Now let me graph one absolute function, okay? Let me graph the next function. So we have f of x equals to square root of 4 minus x. So this is our function. So our here input is x, output is f of x. Input x and f of x together, it gives a point. Now, what kind of function is this? So here we have a square root. So this is we call this a square root function. And if we go back to what we did in our last class, its domain is from negative infinity to positive 4, okay? So this function has a domain from negative infinity to positive 4. Now what does it mean? Can we pick any number as an input for this function? Our domain is from negative infinity to positive 4. Now can we pick any number as an input for this function like we did for previous two functions? Now in this case we cannot pick any number, okay? Your input has to be less than or equals to 4. You can pick any number which is less than or equals to 4. If you pick a number greater than 4, you do not get an output, okay? So let's start with positive 4. So when our input is 4, what is our output? So we have square root 4 minus 4. Square root of 0 and square root of 0 is 0. So 4, 0 is 1 point. Now, so what number do you want to pick? You can pick 3, but what happens if we pick 3? We get square root 4 minus 3. Square root 1, square root of 1 is 1. So 3, 1. Now what number do you want to pick next? 0. So if our x is 0, we get square root 4 minus 0. That is square root of 4 and that is 2. So 0, 2. Now what number do you want to pick next? Negative 2. You can pick negative 2. Now let's see what happens if we pick negative 2. We have 4 minus 2. That is 6. Square root of 6. So what is the square root of 6? We get some decimal number, right? So instead of that, so let's pick a number so that we get a whole number as our output. It will be easy for us to graph, okay? So let's try to make it 9. So let's pick negative 5. So if our input is negative 5, but you can pick negative 2, okay? It's not wrong. So if our input is negative 5, what happens, or what is our output? So we have 4 minus 5. That is 4 plus 5, 9. Square root of 9 is 3. Okay? So negative 5, 3 is the other point. Now let's pick one more input. So what input do you want to pick? So we know the square root of 16 is 4, right? So how can we make 16 here under the radical sign? Negative 12. Okay, so let's pick our x as a negative 12. So if our x is negative 12, we have 4 negative 12, that is 16. Square root of 16 is 4. So negative 12, 4. But you are allowed to pick any number less than or equals to 4. Okay, if you want a decimal, you can pick, okay? Now, once we have this, let's go ahead and graph this. So to graph, we have a horizontal axis, we have a vertical axis here. Now what is our horizontal axis? It's x, and our vertical axis is f of x. That's the output. So 2 4, so 2 4 6 8 10 12, so -2, -4, -6, -8, -10, -12. So -2, -4, -6, -8. Now 4 0. So 4 0 is here. 3 1. 3 1 is here. 0 2 is here. -5 3. This is 4, -5, and 3 is here. -12 4. -12 is here. 4 is here. Okay, so our graph looks like this. So you can extend your graph all the way to the left, but there is no graph on the right from 4. So this is our square root function, and if you have your square root function, you always get a graph very similar to this one. Okay, any question up to here? I'm sorry. So this is, so since here we have a square root, we call this a square root function. Okay, now the next here, let me graph one more, and the function is f of x equals to absolute value of x, and we have an absolute value expression. We call this absolute value function. Okay, now to graph, we have our input x, our output is f of x. Input and output together, it gives a point. Okay, yes. I'm sorry. So he in
like some of the parabolas, others is just like a straight line. So that's one.
the graph depends on the equation. Okay, but if you have like a cubic function, so this is a square root function, and if you have a square root function, your graph is very similar to this one. Okay, every square root function has a very similar graph, not exactly every cubic function has a very similar graph here. Okay, in the similar way, all quadratic function has a graph which we call parabola. Okay, now here we have an absolute value function. Now what is the domain for this function? What we had in our, okay, we did find the domain, right? So for this, all real number is domain. It means we can pick any number as an input. So let me pick a -4. So if, sorry, that is our output. So let me pick x equals to -4. Now if our x is -4, what will be the output? How do we find the output here? You replace x by your input, -4. What is absolute value of -4? What is absolute value of -4? +4. So -4, +4 is 1 point. Let's take -3. Absolute value of -3 is +3. So -3, +3. Let's take -2. The absolute value of -2 is +2. So -2, 2. Let's take -1. So we have +1, -1, 1. Let's take 0. What is the absolute value of 0? 0. So 0, 0. Now let's take some positive number. So if x is 1, what is the absolute value of 1? That is 1. So input 2, absolute value of 2 is 2. So 2, 2. Input 3, absolute value of 3 is 3. So 3, 3. One more. Input 4, absolute value of 4 is 4, 4, 4. Okay, so these are the points. Now we plot these points and we get the graph. So we have a horizontal, and that is our x. We have a vertical, and this is our f of x. So this is 1, 2, 3, 4, 5. 1 2 3 4 5. This is 1, this is 1 1 sorry, -1, -2, -3, -4, -5, -1, -2, -3, -4, -5. Okay, -4, +4. Where is that? 1 2 3 4, 1 2 3 4. Okay, so we have here -3, +3. So -3 is here, +3 is here. -2, +2. -2 is here, +2 is here. -2 1. So -1, +1, that is 1. 0 0 is here. 1 1 is here. 2 2 is here. 3 3 is here. 4 4 is here. And if we have an absolute value function, our graph looks like a V. Okay. So for every absolute value function, our graph is always V. It always looks like a V. Quadratic function is U, okay? Parabola. Absolute value function is V. Okay, any question in graphing a function? So make sure to pick more points, okay? If you have more points, you are getting more accurate graph. So 2 is not enough, okay? 2 point is only for a straight line. If you have your function other than a linear, we always pick more points, okay? Okay, so if you do not have any question, we'll go back to the next topic here. So here, okay, do you recall what do we call this kind of function here? So in this function, our function is h, input is x, okay? Now, when our input x is less than 0, our output is x squared. When our input x is greater than equals to 0 and less than 3, our output is x plus 1. And when we have an input greater than equals to 3, our output is -1. So for different set of input, we have different output. And if for different set of input, we have a different output, we call this a piecewise function, okay? And before we graph this piecewise function, let me go back to the piecewise function that we had earlier, okay? So it should be in a section 2.3. So here we had a piecewise function, okay, this one. So let's start graphing this piecewise function, okay? Okay, so let me erase this one here. So let's graph this piecewise function. So our horizontal axis is x, vertical axis f of x or y, okay? So this is 1 2 3 4 5 1 2 3 4 5 -1 -2 -3 -4 -5 -1 -2 -3 -4 -5. Okay, now we have 3 inputs, okay? So we have the input when our x is less than equals to -2. Now -2 is here, okay? Less than -2 means we will get one type of graph on the left of -2, okay? We will get one kind of graph. Now the next input is we have a input in between -2 and +1. So from -2 to +1, we will get one kind of graph, and that graph is given by these 2. And for our x greater than equals to 1, we get a different graph. For x greater than equals to 1, we get different graph. Okay, so here we have a 3 different set of input. Okay, so every number less than equals to 2, this is one set of input. From -2 to +1, this is another set, and every number greater than or equals to 1 is the third set. For each set of input, we have a different graph, and that graph is given by these outputs. Okay, now let's take our input which is on the yellow region. So let's graph this part at first. Okay, so forget about these two. So if we forget about these two, what do we have? Our f of x equals to -1. And what kind of graph is f of x equals to -1? So f of x is same as y, right? So what kind of graph is y equals to some number? Is it a horizontal line or a vertical line? It's a horizontal line. Okay, so if we have, so this is what we, so if we have y equals to some number, let's call b, then your graph is always horizontal line. If you have x equals to some number, then it is a vertical line. Okay, in our case, just we are taking this part here. So if you replace your f of x by y, we have y equals to -1. Okay, so we draw a horizontal line at -1. Okay, in the yellow region. You do not draw on the green and blue region. So let's draw a horizontal line at yellow region. Okay, at -1. So -1 is here. So this is -1. So our yellow region starts from -2. So from -2, you draw a horizontal line at -1. Okay, so this is a graph, and you can extend this graph all the way up to -infinity. Now, why can't we extend this graph on the right from -2? Because our input x has to be less than or equals to -2. Okay, if we go right from -2, we get x -1, 0, 1, and this is not less than -2. Okay, so this is a graph for our first one. Now let's take the next set of input. So let's take this part, okay, the green part here, and we have f of x equals to some number. It means this is also a horizontal line, and we draw a horizontal line at y equals to 2 on the green region. Okay, so y equals to 2. So this is 1, this is 2. So we draw a horizontal line on the green region. Okay, now here, so we have a closed circle at this point. It means -2 is included. Now in the green region, is our -2 and +1 included here? We do not have equals to sign here, right? It means -2 and +1 are excluded, and we represent that by open circle at -2 and open circle at +1. Okay, so this graph is in between -2 and +1, not at -2, not at +1. Okay, now next let's take the third part. So we have the blue region here. So we will graph this part. So here we have f of x equals to +4. We get a straight line. So we draw a straight line at 4. Okay, in the blue region. So this is 1, 2, 3, 4. So our blue region starts from here. Okay, we draw a horizontal line. Okay, you can extend all the way up to +infinity. Now, do we include +1 in this graph or not? We have our x equals to 1. It means we have a closed circle at this end. Okay, so we have closed circle at this end, and this is a graph for this piecewise function. So on your next exam, you will have a one piecewise function and you will be asked to graph. Okay, you should know how to graph piecewise function. Okay, now can I go back to the example that we are required to do in page 7? Any question up to here? Okay, now let's go back to page number 7, and here we have a piecewise function. We have to graph this piecewise function. Okay, so let's draw our horizontal axis, which is x, and vertical axis, which is h of x. So this is 1 2, so this is 1 2 3 4 5 6, 3 4 5 6 7, negative 1, negative 2, negative 3, negative 4, negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. Now we have 3 input. Okay, we have 3 set of input, x less than 0. So every number of 0 is origin. Okay, so we have one set of input from 0 all the way to the left. So this is, you will get one type of graph here, and that graph is given by x square. Now the next set of input is any number which is greater than equals to 0 and less than 3. So from 0 to 3, so we will have one set of graph here, and that graph is given by x plus 1. And the next part is x greater than equals to 3. So every number equals to 3 or greater than 3, we will get one graph here, and that graph is given by negative 1. So we have 3 different set of input, and for these 3 set of input we have a different output, means we have a different graph. Okay, so we have one type of graph on this blue region, another type of graph in the green region, and the third type of graph in the yellow region. Okay, we do not get same graph for a piecewise function. Okay, now here we will get a 3 different type. Now let's start with the our very first set of input. So let's start with our input less than 0. Okay, so let me write down. So let's forget about the remaining 2, and we have h of x equals to x square. Our x has to be less than 0. Let's graph this part. Okay, and we graph this only in the blue region. Now to graph we need a points, right? So how do we find the points? You choose any number input, your output is h of x, input and output give us a point. Now what kind of number are we allowed to pick for this part here? Can we pick any x? No, it does tell us what x to pick. If the x has to be less than 0, you can pick any x which is less than 0. Okay, so let's start with negative 1. So if our input is negative 1, what will be our output? You replace this negative 1 by x, and negative 1 square is positive 1. So we have negative 1, positive 1, 1 point. Let's pick x equals to negative 2. Negative 2 square is positive 4. So negative 2, positive 4. So let's pick negative 3. We get 9. So negative 3, 9. I think these 3 points should be enough. Now let's plot this point on the blue region here. So negative 1, positive 1. So negative 1 is here, positive 1 is here. So we have this point here. So negative 2, 4. Negative 2, 1, 2, 3, 4. This is negative 2, 4. Negative 3, 9. Negative 3 is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, somewhere here. Okay. Now we connect this graph. Now, how far can we go on the left side? So our blue region is all the way to the positive infinity, right? It means we can go all the way up to negative infinity. Okay. Now, on the right end, how far can we extend this graph on the right? Our x is less than 0, right? Now we can extend our graph up to 0, but we cannot cross 0. Okay, so let's extend this graph up to 0. So our x equals to 0 is here. Okay, so we we extend up to 0. But at 0, is it open circle or a closed circle? There is no equals to 0, means it has to be open circle. So when you extend your graph up to 0, you draw a open circle at 0. Okay, so this is a final graph for our first part. So this is our first point, this is our second point, and this is our third point. And do not forget about this open circle. Okay, now the next we have a green region. So green region means we are taking this part. So our h of x is x plus 1, and our x has to be greater than equals to 0, less than 3. What kind of function is this? This is a linear function. We get a straight line, and if we have a straight line, 2 points should be enough. So let's have our input x, output is h of x, input, output, it gives us a point. Now, what kind of number can we pick here as our input? Can we pick any number? So number has to be between, it has to be equals to 0, greater than 0, and less than 0, less than 3. Can we pick 0? Yeah. So let's pick 0. So if our x is 0, you substitute here, 0 plus 1, 1. So 0, 1. So we can pick 2. So 2 plus 1, 3. So 2, 3. So since this is a straight line, 2 points should be enough. Okay, let's plot these 2 points. So 0, 1. 0, 1 is on the y-axis. Okay. 2, 3. 2, 3. Okay, this is 2, 3. Now let's connect these 2 dots. We get a straight line. Now, how far can we extend this graph on the left and on the right? Now, how far can we go on the left for this graph? It's starting from 0, right? So it's starting from 0. So we have a closed circle at the first end. So closed circle. Now on the right, how far can we extend this graph on the right side? Up to 3. Okay, but when you reach at 3, what we need? We need a open circle. So when you are at 3, we need a open circle, because 3 is not included in this domain. Okay, so this is a graph for our second part. Now for the yellow region, this is easy. So it's very similar to what we did earlier. For yellow region, we have h of x equals to -1, and our input is greater than equals to 3. So what kind of graph do we get here? H of x equals to -1 means it's a horizontal line. Okay, so we draw horizontal line at -1. So our -1 is here, but make sure to draw horizontal line on the yellow region. Okay, at -1. So you draw horizontal line. How far can we go on the right? All the way up to positive infinity. Now what about at 3? So this is 3. On the left end, do we have an open circle or a closed circle here? Closed, because 3 is included here. So we have a closed circle here. Okay, and this is the final graph for this piecewise function.